The question is, the function cos x is approximated using Taylor series around x is equal to 0 as cos x approximately 1 plus ax plus bx square plus cx cube plus dx power 4. The values of a comma b comma c and d are 4 options a b c d given. This question is from engineering mathematics from the topic differential calculus subtopic Taylor series. The solution is from GATE 2021. So this is Taylor series around x equal to 0. The other name for Taylor series around x equal to 0 is called Maclaurin's series. So we know from Maclaurin's series, that is Taylor's series around x is equal to 0, comma, cos x is equal to 1 minus the square by 2 factorial plus x power 4 by 4 factorial minus so on. So this can be written as 1 plus 0 into x plus minus 1 by 2 into x square plus 0 into x cube plus 4 factor value 24, 1 by 24 into x power 4 plus x. So let us say this is equation 1 series, and cos x approximated as given 1 plus ax plus bx square plus cx cube plus dx power 4. Comparing 1 and 2, we get that is like terms to be equated. 1 is equal to 1 constant. So coefficient of x is nothing but now a is equal to 0. Coefficient of x we're equating. B is equal to minus 1 by 2. Coefficients of x cube equating, we'll be getting C0. Coefficients of x power 4 equating, that is d is equal to 1 by 24. So 1 by 24 is approximately 0.042, and minus 1 by 2 is decimal fraction is minus 0.5. So the answer is A0, E minus 0.5, C0, E is equal to 0.042. So accordingly, the option is D. This is the end of the question. The question is, the probability distribution function of a random variable x is shown in the following figure. On x-axis 1, 2, 3, whose corresponding fx value 0.5, and beyond that 1, 2, 3, the graph lies on x-axis, that is function value 0. From this distribution, random samples with a sample size, comma, n is equal to 68 are taken. If x bar is the sample mean, comma, the standard deviation of the probability distribution of x bar, that is sigma x bar, is round off to 3 decimal places. This question is from engineering mathematics from the topic probability and statistics, subtopic random variables, distributions, samples. The solution is, here I am writing, from the graph, write the corresponding function values. That is fx is equal to, for x lies between 1 to 3, the function value is 0.5. If 1 less than or equal to x less than or equal to 3, 0 other values of x. That is x greater than, x less than 1 as well as x greater than 3. This is when a function lies on, when the graph lies on x-axis, corresponding y value, that is function value fx value 0. So is the, because here it is a continuous random variable, probability density function, that is PDF, of a continuous random variable, RV stands for random variable fx. So we need to find sigma x bar. First of all, x bar mean x bar is nothing but expected value of x. This is mean average. In continuation, integration over all x values, x times into f of x dx. So that means 0.5 times x dx. This 0.5 function where x values lies between 1 to 3. So 0.5 is a multiplication constant into x integration with respect to x is x square by 2 between the limits 1 to 3. So 0.5 is 1 by 2. This is already 1 by 4. 3 square minus 1. So this is 9 minus 1. 8 by 4 is 2. Next, to find standard deviation, sigma or variance, we need to find expected value of x square. That is integration taken on all x values, x square times f of x dx. That means integration 1 to 3, because other values of x, fx value 0, 0.5 into x square dx. 0.5 is 1 by 2. X square integration with respect is x cube by 3. Between the limits 1 to 1 by 6 into 3 cube 27 minus 1. 26 by 6 means 13 by 3. Therefore, variance of x is equal to expected value of x square minus expectation of x whole square. So this is 13 by 3 minus 4. This is equal to simplifies to 1 by 3. Okay. So therefore, standard deviation of x is sigma suffix capital X is equal to square root of variance of x. Nothing but 1 by square root of 3. Therefore, the question requires the standard deviation of the probability distribution of x bar, that is sigma x bar. The above step is sigma with respect to x. Now sigma standard with respect to x bar. Okay, so this is sample mean actual x bar is given by the formula sigma suffix capital X divided by square root of n. That is standard deviation of the given x values divided by square root of n. So n is already given 68. Okay, so sigma just now we calculated with respect to x 1 by root 3 times root over 3. So this is simplified to 1 by square root of 204 approximately. So the question required to up to round of 3 decimal places. So this is point not 7 not, that is 0.070. So the answer is 0.070. This is end of the question. The question is, let A be a square matrix of side n cross n in bracket n greater than 1. The elements of A is equal to matrix Aij, where that means are given by Aij is equal to I into j if I greater than or equal to j, 0 if I less than j. The determinant of A is 4 options A, B, C, D given. This question is from engineering mathematics, from the topic linear algebra, subtopic basics, that is determinant. GATE 2021 solution is, so first consider 2 cross 2, 3 cross 3 and then generalize using mathematical induction, or you can consider directly n cross n matrix also. Okay, the elements 0 here, where I less than j. I less than j, the corresponding elements Aij are called elements above the diagonal. Okay, I greater than j means elements below the diagonal. Here it is given. So I can go for directly A n cross n square matrix. What is that? Generally A11 first row first column element, A12 so on, A1 second row elements, A21, A22 so on, A22 so on, AN1, AN2 so on, ANN. So n cross n square matrix. According to that, this condition, Aij, I greater than j. I greater than j, I equal to j means diagonal elements. I greater than j. For example, here 1 less than 2. It is not 1 greater than 2. A21, 2 greater than 1. I means first suffix, A means second suffix. Usually I indicates row position, j indicates column position whenever the element is generated by A. So here elements below the diagonal non-zero, above the diagonal I less than. So A11, that means 1 into 1. Okay, 1, 0, 0, so on. A21, that is 2 into 1. A22, 2 into 4, 2 into 2, 4. Next, 0, 0, 1, 0. Next, like this. Last, n into 1, n. N into 2, 2n. 1. N into n, n. So this is n cross n square matrix. Whose diagonal elements 1, 4, so on n is lower triangular matrix. Determinant of a triangular matrix, that is lower or upper, or diagonal matrix or scalar matrix, is nothing but product of its diagonal elements, principal diagonal elements. So implies determinant of matrix A is product of its main diagonal elements, that is principal diagonal elements, which is nothing but first diagonal element is 1, second diagonal element is 4, third diagonal element A33, that is 3 into 3, 9, nth diagonal element so on, n into n, n square. All are perfect square, 1 square, 2 square, so on, n square. These are in product A, B, C, D whole square, nothing but A square, B square, C square, D square. So 1 into 2 into 3 into so on into n having common square. That is a b whole square is nothing but a square into b square. This is 2 square. This is 3 square. So product of first n natural numbers. That is first n continuous natural numbers. That is 1 into 2 into 3 so on n is always n factor. So n factorial. Square of n factorial. Product of the first n natural numbers is always n factorial. So if you feel difficulty, particular case I will share. Let n is equal to 3. 3 by 3 matrix. A 3 cross 3 containing 9 elements. A11, A12, A1, A21, A22, A23, A31, A32, A33. So according to the given condition, this is 1 into 1, 1, 0, 0, 2 into 1, 2, 2 into 2, 4, 0, 3 into 1, 3, 3 into 2, 6, 3 into 3, 9. So implies the determinant A product of the diagonal elements because lower triangular matrix 1 into 4 into 9. This is an element 1 into 2 into 3. Because I took 3 by 3 matrix, we got up to 3 product of the first 3 next number square. So 3 factorial. So the answer is n factorial whole square. Accordingly, the option is C. This is end of the question. The question is A comma B comma C and D are vectors of length 4. A is equal to row matrix A1, A2, A3, A4, that is row vector with 4 components. Similarly, BCD, B is equal to row vector B1, B2, B3, B4, C is equal to row vector C1, C2, C3, C4, D is equal to row vector D1, D2, D3, D4. It is known that B is not a scalar multiple of A, full stop. Also, C is linearly independent of A and B. Further, D is equal to 3A plus 2B plus C. The rank of the matrix, 4 by 4 matrix. First row A1, A2, A3, A4. Second row B1, B2, B3, B4. Third row C1, C2, C3, C4. Fourth row D1, D2, D3, D4 is. This question is from engineering mathematics from the topic linear algebra, subtopic basics and rank. Solution is, so here I can write a statement between independent dependent vectors. Two vectors A and B are said to be linearly dependent if one is a scalar multiple of the other. Linearly independent means between two vectors. This definition related to between two vectors. Similarly, it is true for other vectors. Independent if one means one vector is not a scalar multiple of other. So now given B is not a scalar multiple of A. which implies A comma B are linearly independent. The short form Li is nothing but linearly independent. Given C is linearly independent of A and B, which implies A, B, C, the three vectors are linearly independent, or Li. Li stands for linearly independent. Now, since E is equal to 3A plus 2B plus, that is, E is expressed as the linear combination of the vectors A comma B comma C. Linear combination means sum of the scalar multiples. So, therefore, D is linearly dependent on A comma B comma C. That is on A comma B comma C. That means the number of linearly independent row vectors from given A, B, C, D, from four vectors, three linearly independent vectors. Hence, rank of matrix A, let us denote the given matrix 4 by 4 matrix A, is 3. Since rank of any matrix A equal to number of linearly independent, that is Li, rows or columns or both. That is rows comma columns are also called vectors. This is the statement properties from the rank. So finally the answer is 3. This is end of the question. The question is, for the function f of x is equal to minus x, comma, x less than 0, x square, x greater than or equal to 0. The correct statements is are 4 statements ABCD given. Fx is continuous at x equal to 1, fx is differentiable at x is equal to 1, fx is continuous at x equal to 0, fx is differentiable at x equal to 0. This question is from engineering mathematics from the topic differential calculus, subtopic continuity, limits, differentiable, from GATE 2021. The solution is the function is defined in different subintervals: negative real numbers minus x, positive 0, greater than or equal to 0. So, according to limits procedure, that is for proving continuity differentiable at a point 0, left hand derivative, right hand derivative, left limit, right limit, etc. LHL, that is left hand limit at x is equal to 0. Limit x tends to 0, x less than 0, f of x. So when x less than 0, the corresponding fx is minus x. So this is a polynomial function, direct substitution, that is 0. RHL of the function f of x at x is equal to 0. The notation limit x tends to 0 plus and 0 plus can written as x tends to 0, x greater than 0. Similarly, left hand limit denoted by x tends to 0 minus whenever you are calculating at x equal to 0. That 0 minus is also written as tends to 0 less than f of x. So when x greater than 0, here when x less than 0, the corresponding fx when x greater than 0 is x square. So this is limit x tends to 0, x square. Again, direct substitution, this is 0. And f of 0, that is function value, fx value at x equal to 0. How much? Is nothing but 0 square 0. So, which implies left hand limit at x equal to 0 is equal to right hand limit at x equal to 0. That is limit of f of x at x equal to 0 is also 0, which is equal to function value at x equal to 0. From this, f of x is continuous at x is equal to 0. Okay. So, C is correct. Now, coming to, since fx is equal to x square for all positive numbers including 0 is a polynomial function. So polynomial function is always continuous as well as differentiable. Therefore, f of x is continuous right typing mistake. F of x is continuous as well as differentiable, that is standard function. X square derivative 2x at x equal to 0, it is having 0. Differentiable at x is equal to 0. So already this is we proved continuous at x equal to 0. So now I can say differentiable at x equal to 0 and differentiable polynomial function at x is equal to 1 also. Now let us check continuous at x equal to 1 or that means continuous fx is continuous at x equal to 0. We got differentiable at x equal to 0 we got. This kindly excuse me. Fx is continuous and differentiable at x equal to 1. We have to prove differentiable at x equal to 0 or not, because at x greater than 0, at x less than 0, different function values, but all positive values of x, the function is one value, that is x square. So kindly excuse me. Now fx is continuous polynomial function and differentiable for every positive value of x, including, that means we already proved continuous at x equal to 0. We have to check whether it is differentiable at x equal to 0, but I am talking about x greater than 0, positive real values of x. Here fx is continuous and differentiable at x is equal to 1. So actually a polynomial function is continuous at every real number, but 0 is a real number. Why we have to check at x equal to 0, especially continuous and differentiable. That is a procedure from the standard limits. I mean, standard procedure for continuity differentiability limits. Whenever a function defined in different subintervals, for example, when x less than 0, when x greater than 0, you have different functions. Then you have to check continuity as well as differentiability. So, LHD, left hand derivative at x is equal to 0. This is left hand derivative of the function f of x at x equal to 0. So, what is the notation? LF dash. So, that is limit x tends to 0 minus. That is x tends to 0 minus means x tends to 0, x less than 0. F of x minus, this is slope, f of 0 divided by x minus 0. When x less than 0, the function value is minus x. So, this is limit x tends 0 minus x. F of 0 is 0 square 0 divided by x minus 0 means x cancelled. So, limit x tends to 0. Remaining is minus 1. Limit of a constant is itself. So, you will be getting left hand derivative minus 1. RHD, right hand derivative of f of x at x is equal to 0. This abbreviation is RF dash 0. Equal limit x tends to 0 plus and bracket x tends to 0, x greater than 0, f of x minus f of 0 divided by x minus 0. When x greater than 0, the corresponding function value is x square. So this is limit x tends to 0, x square, function value 0 square, that is 0. Divided by x, on x cancel. This simplifies to limit x tends to 0, x on by direct substitution, you will be getting 0. So LHD at x equal to 0 not equal to right hand derivative RHD at x equal to 0 implies f of x is not differentiable at x is equal to 0. With this statement and with this statement. So continuous at x equal to 0 and at x equal to 1, differentiable at x equal to 1. So this is not true. Okay. So therefore, A, B, C are correct. Okay, here second method for differentiation without LHD after polynomial function. Okay, f dash x in the first case when x less than 0, you will be getting minus 1 comma x less than 0. X square derivative 2x, you will be getting the corresponding x values x greater than or equal to 0. So f dash x tends to 0 minus, you will be getting minus 1, and f dash x at x tends to 0 plus, that is right hand derivative, you will be getting 2x. After that, x tends to 0, it is nothing but 0. So that is left hand derivative not equal to right hand. Okay, so that f of x is not differentiable x equal to 1. So the first three A, B, C are correct. This is the answer. This is the end of the question. The question is a three-dimensional velocity field is given by V is equal to 5x square y I plus cy j minus 10xy z k, where I comma j comma k are the unit vectors in x comma y comma z directions respectively, describing a Cartesian coordinate system. The coefficient of C, the coefficient capital C, is a constant if V describes an incompressible fluid flow, comma, the value of C is. Four options A, B, C, D given. This question is from engineering mathematics, from the topic vector calculus, subtopic divergence, etc. The solution is, so here incompressible fluid flow is underlined. That is the main terminology. Fluid mechanics, that means technical subject, one of the subject fluid mechanics, you will get compressible, incompressible fluid flow. So this is the vector given, three-dimensional vector. Solution, this is from GATE 2021. For an incompressible fluid flow, we have divergence of this vector v is equal to 0. How do you find the divergence? I times, sorry, divergence is a scalar quantity. Ij are vectors. So, sum of the three first order partial derivatives, that is dou by dou x of I bar quotient plus dou by dou y of j bar quotient plus dou by dou z of k bar quotient. Usually, I coefficient denoted by f1, j coefficient denoted by f2, k coefficient denoted by f3. That is mathematical notation. Dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z is equal to 0. All the partial derivatives, first order partial, which implies 5x square y with respect to x partially derivative is y constant 10xy plus cy with respect to y derivative c is a constant, you will be getting capital C, y derivative is 1 plus minus 10xyz with respect to z partially gives minus 10xy is equal to 0. So plus 10xy minus 10xy got cancelled, you will be getting c is equal to 0. So the answer is 0. Accordingly, the option is A. This is end of the question. The question is an ordinary differential equation ODE, comma, dy by dx is equal to 2y with an initial condition y of 0 is equal to 1 as the analytical solution y is equal to e to the power 2x. Using Runge-Kuttas second order method, numerically integrate the ODE to calculate y at x equal to 0.5 using a step size of h is equal to 0.5. If the relative percentage error is defined as epsilon is equal to y analytic minus y numerical divided by y analytic plus into 100, then the value of epsilon at x equal to 0.5 is. This question is from engineering mathematics, from the topic numerical methods, subtopic numerical solution to ODE from GATE 2021. The solution is from the first order differential equation, usually dy by dx is equal to f of x comma y. This is 2y is nothing but function of x comma y. From this gives y naught value 1, x naught value 0. This is exact solution. Analytical solution is also called direct or exact solution. The method mentioned, Runge-Kuttas second order method, which is also called Euler's Cauchy method, improved Euler's Cauchy method, or Euler's predictor corrected method, or modified Euler's method, etc. So many names. So we should calculate solution y at x equal to 0.5 using step size also given h. Now percentage error with the relative modulus is given here. Absolute percentage error actually. So solution, data from the data. What are the notations? F of x comma y. To y where x is absent. Y naught value 1, comma, x naught value 0. Step size value 0.5. Now we need to calculate y of 0.5 is equal to question mark. So this y of 0.5 is also y of y1. Y1 means the y value at x1. So x1 means x0 plus h. That is h value 0.5. That is finally y of 0.5. First of all, we need to calculate y. So analytical solution. Analytical solution at x is equal to, they are asking at x equal to 0.5. Finally, the e value. But we need to find at x equal to 0.5 numerical solution as well as analytical solution. Then only we can substitute here. At x equal to 0.5 is e to the power 2 into 0.5. That is e to the power 1. value 2.7182 approximately. So because they mentioned any two decimal places, okay. On according to the options, the maximum number of decimal places is 2. I can write approximately this is 0.72. Okay. Next. The numerical solution is obtained from the second order method. Okay. By second order Range-Kutta method, comma, y1 equal to y0 plus half times k1 plus k2, where k1 is equal to h times f of x0 comma y0, h is 0.5 into function value at x0 means 0, y0 value 1. So function of x comma y is 2y, so 2 into 1 finally this is 0.5, 2 into 1, so this becomes 1, and k2 h times f of x0 plus h comma y0 plus k1. So 0.5 into function value x0 plus h, that is 0.5, y0 value 1, k1 value 1, 1 plus 1 2. So how do you calculate this function of 0.5 comma 2? That is in the function of x comma y, put x equal to 0.5, y is equal to, this is equal to 0.5 into 2 into y, that is 2 into 4 into 0.5 is 2. So there y1 is equal to y0 1 plus half times k1 1 plus k2 value 2. So 3 by 2 value is 1.5. So this is 2.5 is the numerical solution. Numerical solution at x is equal to 0.5. So this 2.5 now it is y numerical, and this 2.72 is y analytical. Therefore, epsilon is equal to modulus y analytical how much? That is 2.72 minus y numerical 2.5 divided by y analytical 2.72 modulus close into 100. So simplify this, you will be getting 8.08 approximately 8. So the answer is 8 or 8.0. Accordingly, the option is A. This is the end of the question. The question is, to solve an algebraic equation f of x is equal to 0, comma, an iterative scheme of the type xn plus 1 is equal to g of xn is proposed, where g of x is equal to x minus f of x by f dash x. At the solution x is equal to s, comma, g dash s is equal to 0 and g double dash s not equal to 0. The order of convergence for this iterative scheme near the solution is. This question is from engineering mathematics, from the topic numerical method, subtopic numerical solution to algebraic equations f x equal to 0. Okay. So this is looks like x minus fx by f dash x Newton-Raphson method iterative scheme. So order of the convergence we know that quadratic, that is 2. Okay. So anyhow, solution, this is from GATE 2021. Xn plus 1 is equal to given g of xn, where g of x is how much? X minus f of x divided by f dash x. Substitute g of x here in the g of xn, which implies xn plus 1 is equal to xn. So in this gx put xn, put x is equal to xn minus f of xn divided by f dash xn, which is the Newton Raphson iterative scheme, iterative scheme. Hence, comma, order of convergence for this iterative scheme near the solution is quadratic. That is 2. So the answer is, that is order of convergence is 2. This is end of the question. The question is, for the ordinary differential equation d cube y by dt cube plus 6 times d square y by dt square plus 11 dy by dt plus 6y is equal to 1 with initial conditions y of 0 is equal to y dash 0 is equal to y double dash 0 is equal to y triple dash 0 is equal to 0. The value of limit y of t tends to infinity is equal to round off to 3 decimal places. This question is from engineering mathematics, from the topic either differential equations, higher order linear differential equation with constant coefficients, or Laplace transform. Using Laplace transform, we can get the answer, which is from GATE 2021. The solution is so I am going to solve by Laplace transform technique. Writing the given all derivatives in superscript form, that is prime notation, let L of y of t is equal to capital Y of s, that is Laplace transform of y of t is equal to y of s. Y of t is the solution actually for the differential equation, and L stands for Laplace transform. Laplace transform of t variables gives s variables. So dg can be written as, that is implies y triple dash t plus 6y double dash t plus 11 times y dash t plus 6y is nothing but y of t is equal to 1. This is equation. So taking Laplace transform, LT stands for Laplace transform, on both sides of equation 1, we get L of y triple dash t plus 6 times L of y double dash t plus 11 times L of y dash t plus 6 times L of y of is equal to L of 1. So using Laplace transform of derivatives and standard Laplace transforms, you will be getting s cube into capital Y of s minus s square into y of 0 minus s y dash 0 minus y double dash 0 plus 6 times s square capital Y of s minus s times y of 0 minus y dash 0 plus 11 times Laplace transform first derivative is s times y of s, capital Y of s, minus y of 0, small y of 0, plus 6 times Laplace transform y of t is capital Y of s. Laplace transform constant is constant by s, that is 1 by s. Since Laplace transform of derivatives, now given y0, y dash 0, y double dash 0, y triple dash 0 are 0. So this is 0. This term also becomes vanished. This is 0. This is 0. This is 0. This is 0. Now first collect all ys terms, take ys common at the left side, remaining if any terms shift into right side. So this can be expressed as taking y of s, capital Y of s common, s cube plus s square plus 11s plus 6 into capital Y of s, and the right side, the remaining term is already 1 by s. So this is a factorizable. Product of three linear factors will be giving s plus 1 into s plus 2 into s plus 2. From this, find y of s, dividing by both sides the coefficient of y of s, which gives capital Y of s is equal to 1 by s into s plus 1 into s plus 2 into s plus 2. Let us say equation. To find the solution y of t, taking inverse Laplace transform on both sides of equation 2. Before that, the partial fractions method is applicable. It implies capital Y of s is equal to all are four distinct linear factors. So according to the partial fraction method, this is a by s plus b by s plus 1 plus c by s plus 2 plus d by s plus 2, since partial fractions. Now, after finding capital A, B, C, D, you will be getting capital A value 1 by 6, capital B value minus 1 by 2, that is into s plus 1, capital C value plus 1 by 2, this is 1 by 2 into s plus 1. So capital D value minus 1 by 6, that is minus 1 by 6 into s plus 3. Now taking inverse Laplace transform, we get on both sides L inverse y of s is nothing but y of t. This is 1 by 6. All the multiple constant take outside. L inverse 1 by s minus, according to linearity property, half into L inverse 1 by plus 1 plus half into L inverse 1 by s plus 2. Sorry, this is 2 s plus 2 minus 1 by 6 into L inverse 1 by s plus. So from this, you will be getting 1 by s inverse is 1. 1 by s plus inverse is e power minus t. Here is already half. 1 by s plus 2 inverse is e power minus 2t divided by 2. 1 by s plus 3 inverse is e power minus 3t. Minus e to the power minus 3t by, now implies limit t tends to infinity y of t. When t tends to infinity, e power minus infinity 0. So 1 by 6 minus 1 by 2 into 0 plus 1 by 2 into 0 minus 1 by 6 into 0. So finally simplifies to 1 by 6. And limit t tends to infinity, e power minus t is equal to 0, comma, e power minus infinity is, okay. So second method, later you do. I'm giving the suggestion, find CF complementary function before write means after Hope that understood. Not writing auxiliary equation, all these words. Complementary function based on that roots of the auxiliary equation, comma, pi, particular integral implies solution is y is equal to cf plus pi. Independent variable is t variable. Solution variable, numerator variable, dependent variable is y. Then use given initial conditions for finding C1, C2, C3 constants, and then apply limit. That is a hint. So finally, 1 by 6, but it is a numeric question. So 1 by 6, they are asking up to 3 decimal places underline. So this is, I hope that point 167. Please check. So therefore, y of t, that is limit t tends to infinity, y of t is equal to 0.167. So the answer is 0.167. This is end of the question.